Hello. So in the previous session we have seen how to generate word embeddings using frequency based approach, right? So we have generally classified the generation of word embeddings with two approaches, that is frequency based approach, and the second one is probabilistic based approach. So the frequency based approach is for occurrence matrix or word to context matrix, and for probabilistic based approach is for co-occurrence matrix or term matrix. So let's begin with the probabilistic based approach in order to generate the word embeddings. Yeah, so we generally generate the metrics or word vectors based on the SkipGram model. So I have also explained what are SkipGrams, and I have taken an example of 2 SkipGram model in order to generate a SkipGram. So in the probabilistic based approach we generally follow 3 steps. The very first one is to generate the input to the network or a shallow network. Second step is to convert that input or the words into numerical forms. There we are following one hot vector encoding in order to convert the input data or the SkipGrams generated or the input generated to convert that into a numerical values. And the very last thing is to tune the network, or when to stop or when to end the training of the neural network. So let me brief it again. So it generally carries out 3 steps. The very first step is to generate the input, right? Generate the input to the shallow neural network. Second thing, we are converting that input into vectors or numerical values using one hot encoding. And the very third thing would be applying the certain functions or certain methods in order to fine tune the network and also stop the training of the neural network. So as we have now understood the various 3 steps, we'll first start with the very first step of the generation of the word embeddings using probabilistic based approach. So I will just take an example which is very classic to begin with and also to understand it in a very simple terms. Let me take a sentence or a context where what will be will be. So the probabilistic based approach aims at maximizing the affinity of a word, affinity or a like neighborhood of the word in a given sentence or in a given context. The main aim of the whole process of the generating the word embeddings based on the probabilistic approach is to make or predict the chances of the neighborhoods that are present in a given word for a given context. Let's say I want my neural network or I want my word embedding to understand that if I pass a word will, then I have to get the word or a output as what and be based on a given context. So in the very first step we are trying to generate a input for the neural network. So the input will be looking similar to like this. So this input will be generally containing 2 terms or 2 entities, that is the output or the context expected and the input at the point. So let's take 3 words at a time, and we will try to generate a input and output context for the same. So I will take the first word what, and the output that I will be expecting for that would be will. So I am representing that in this form. This is one of the input. Then next I will take the word will. Since it has 2 neighbors, it will be splitted into 2 inputs, right? So the word would be like, so for the will as an input, the output I will be expecting will be what and be, right? So similarly, if I take an input for the word be, then the output for that word be would be will and will. Finally, if I take a word be at the end, which is at the end, and for that the output I will be expecting, or the neighboring term or the context I will be expecting, will be will. So this is how I will be going to generate a input that is necessary to train my shallow neural network. In this process we have completed generating the SkipGrams basically, right? So we have generated a SkipGram. Now our task would be to convert that into a numerical form or a vectorical form. For that we will be following one hot encoding.